Hello, this is Rich, and again, it's been a while, but I've been working really hard on the implementing my RTS camera in C++, and I think I've got it pretty much almost complete. Actually, it's to a point where it works flawlessly. Last time I made a statement about it being black and white lines shining on the screen and flickering like crazy, and you can't see a single thing. I've since fixed that problem. It's tough when you don't have documentation and you're basically working and learning by yourself and figuring everything out by yourself, trial and error. But I did. I got it fully working. So today we're going to go into actually making your own camera and using it as your primary default. Making a camera for, let's say, over-the-shoulder type of view, top-down view, 45-degree angle, basically any different kind of cameras. The difference is this is done in C++ fully. The way I got it now is my Rts camera done in C++. Rotates, moves just as if it was doing in Flowgraph. This is not using Flowgraph for my camera. This is done in C++. That's why it's been so long since I did this tutorial today, because I've been working non-stop trying to get it perfect so that I can do a full deal with the making a camera. Last code you saw was basically made just for the tutorial. This code here is, you could take this, copy, paste, and you can use it as your own camera. It's fully functional. Only thing to note, this camera, this in C++, it creates the view and links it to an entity. This entity is custom scripted in Lua, which we'll be going over sometime, not in this tutorial. You don't have to script your own entity. You can make use an entity that's in the game. But the entity is moved and rotated with Flowgraph. That's why I get the rotation and the movement of the camera, because the camera is linked to the view. That's what creating the view and linking it to the view, to the entity, is what's done in C++. The actual moving is done through Flowgraph. I'm only moving the entity, not the camera, in Flowgraph. But since the camera is linked to the entity, it gets the same movement and rotation. So let me just jump right in to show you what it looks like fully done. And then we're going to go over how to do it. For those of you who are looking at the tutorials, you might see tutorial number 3, which is how to create an RTS game from start to finish, part 3. That is not new. This is part 4. This currently, what I'm doing right here, is going to be part 4. The part 3 is not something new. It is this programming, the first programming tutorial that I did in C++. But since it's part of the series, I just renamed it to part 3. And this is part 4, continuing programming. It's a good idea to look in the description of each video, as it clears up any confusion people may have. Alright, so let me start up Visual Studio 2010 Express. We will be needing Visual Studio C++ 2010 Express Edition, copy of the 3.3.9 version of Cryengine, 3 SDK, not the mod SDK, the free SDK is what you need, and that's all we'll be needing. Visual Studios and Cryengine 3.3.9. Okay, I'm going right into opening up my Cryengine game code only. And before, this is going to be, I'm trying to be quick with this here, but get enough information in so you guys can understand. We're going to be using the game.cpp, as this is the main game file, which is contains the game loop, which all the game is run in, basically. It has the main update function in this game.cpp. Update function. Update. This function here gets run every single frame. So if any code you put inside of this section here will get run every frame. Where are you? Every code here will get run every frame. Okay, so let's go over what I have done. Previously, we had a Rts Camera.cpp file and an Rts Camera.h file. Remember, I put it in my files, cameras, Rts Camera, Rts Camera.cpp, which holds my definitions, what a function does, and my Rts Camera.h file, same name as a CPP, with all of my declaration saying that we're going to have a function named this. And also it declares the classes we're going to use. Previously, my functions were located in just open world, global space, which is not a good idea. Typically, you want to put these in classes. And we're going to go over classes today because that is what we're making. We're making a class, our own custom class. And that's how I have accomplished this setting the camera, creating the camera and linking it. Also, we're going over these include files. I didn't go over this last time. We have include, and we'll talk about what this means. Okay, before what you saw is you saw this. We went over this. Getting the iView system and putting it in a pointer. The names may be a little bit different than before because these are now part of a class, and we're going to go over that. And this gets the entity system. Remember this gets an entity that's named Game Camera and assigns it to a pointer called this. This gets the entity ID of our entity, which is our Game Camera. And in case you were curious, this entity here, I did not create the entity in C++. This entity I created in Lua, and I put this entity inside of my level. So this code will not work. It will not work unless you have this an entity in your level named Game Camera, because this whole camera is linked to this Game Camera. So if you have a level that does not have the Game Camera entity in it, then it will not work. Right here gets the entity ID of that entity. This activates that entity in case it wasn't already before. This creates a new view, remember, from the iView system, and assigns it to the pointer MP Rts Camera view. This line of code gets our ID of our new view and puts it into the Rts Camera view ID pointer. This right here removes any sort of view that's currently active. This one right here sets our view that we created up here to the active one so that we can see out of it. Otherwise, it's not going to work. You won't be able to see out of the view you created, and that's counterproductive. You want to see out of your view. That's why we're making this code. This is new here. That was before. It wasn't there before. This is new. That wasn't here before. And this is new. That wasn't here before. These things are the new ones added to this tutorial. Don't worry about these. These are not appropriate for this tutorial here. They're really not implemented at all. They were part of an experiment. They're not used. I don't need them. This is also another function. It's part of a class that I made. This is very important. This is one of the reasons why my camera was not working properly. So we're going to go over all of these. I'm just showing you the additions that we made from last time. This is a new addition. It's a function that has a whole bunch of instructions that are being done inside that function called set view params. Again, this is my custom function that I made. And all these three are new. Set view params, which is my own function. Set current params, which is an existing function from Cryengine. And this links the view to our entity so that the view takes on the rotation and movement of our game camera entity that's in our level. So when the game camera entity moves, so will our camera. When a game camera entity rotates, so will our camera, because we've linking it to it. So now we're going to go over how to create a class to get this all working. I'm not going to rewrite all the code for you because I don't want to mess anything up. I will just go over what I have and you can follow along. So my Rts Camera.h file, what we have here is a class that I made, or a struct. They're basically the same thing. In case I didn't describe before, let's go over what a class is. A class, or a struct, is basically, not technically, but basically a big, long variable. And the variable name would be Rts Camera. And an Rts Camera can hold not just values, but a class can hold functions, just like this. These are function declarations. Remember, they don't tell you what the function does. So a class can hold functions. It can hold variables, see, member functions, and they can hold variables. So not only can a struct or a class act like a variable or a type like an int or a bool or a string or a character, it can also hold functions and variables. So basically a class is a way of organizing functions and likewise data into one package, like a package deal. You can refer to them as like a package. Instead of having all these functions declared outside somewhere in some sort of .h file or declaring some variables somewhere just out in the open, this gives it more of a structure. Not struct, I'm not talking about struct, I'm just talking about the word structure, as in it gives your program a little bit more structure, a little bit more organization to package up your files into one little set of data. So how you create a function, and we're not going to go over inheritance today, we're not doing that, I'll go over that in another tutorial. But how you create a class or a struct is you start the word, all lowercase, struct, and then the name. Do you want to name the struct? You can think of this like a variable that holds data. So you need to say struct and then the name. Opening parenthesis, opening curly bracket, and a closing curly bracket. Unlike function definitions where you have a opening bracket and a closing bracket, classes and structs at the end need a semicolon at the end. Otherwise you will encounter undefined behavior, or it will not compile and think you're still trying to define what is this struct. So you need to have at the end a semicolon. So inside of these, first you do struct, your name, opening, closing, and then a semicolon. Inside of these, you have, let's ignore this, you have function declarations, just like the C++ tutorial. We just said, hey, we're going to have a function named this, and this is its return type. Same thing. Inside of a class, you can do that. This is a return type. This is the name of the function right here. This is the return type, string, and this is the name of the function. Return type, name of the function. Same thing. Now I have some variables I want to put in this class. This is a type, View Params, and then the name. View Params is a type, and then the name of the variable. View system, pointer, remember, multiplication symbol is a pointer. I'm making a pointer called MPI View system of type iView system. I'm declaring. I'm not assigning any values to these variables. I'm just declaring. So I have a type I entity system, pointer MP entity system. So I'm creating pointers right now of these types. So I'm basically creating variables in this section here of different types that I'm going to need. And that's what classes basically do. They basically just organize all of your data inside of one little package file. just a little bit more organized that way. Previously, if you didn't put this in a class, if you wanted to, let's say, access View Params, this variable here, current View Params. Previously, if we didn't put this in a class, we can just sit there and, go underscore CUR current VIEW PARAMS to reference that variable, just like that. Well, if you see here, it's giving me an error because it says this declaration has no storage class or type specifier. Basically, this means it doesn't even know what this variable is. It doesn't even know it exists. So before, we could just reference the variable like this. The difference being, because this variable belongs to a class. Why does it belong to a class? Well, it's because it's declared inside of the class. See? Starting of the class, ending of the class. And where is this variable? Right here. It's inside of the class. So this is called scope. Anything that's inside of an opening and closing curly brackets is called, it's in its own scope. Means it's not accessible from anywhere outside of this and this. Since we're trying to use this variable outside of this and this, it doesn't know what we're talking about because down here we're in a different world. So this is like its own little world here because it's in an opening and closing brackets. So we cannot possibly talk about current View Params outside of this ever. And you're probably thinking, so why did you put it into class if you can't even use it? Because you can. With a class, the only difference is when you declare things in class, you have to tell it which class it comes from. And that's what the pointers were about. Remember here, we wanted to get the, find entity by name. That's a function. That's inside of a class. See, this is a function. Void create Rts Camera. That's a function, right? But it's inside of a class. Just like find entity by name was a function that's inside of a class, what did we do before? We found what class it belongs to. And in this case, this function belongs in a class in the entity system. So we have a class called Rts Camera, and there's a function inside of that called create Rts Camera, or a variable called current View Params. So in order to access this variable, because it's inside of a class, you have to do one more step. And this step is, you have to type in the name of the class or struct, Rts Camera, exactly spelt the same way, colon, and that would be how you declare it. I mean, that would be how you use it. Just like that. That's how you use it. You can see I'm getting an error here because in this current instance here, the way I'm using it is not appropriate. But this right here is the main way you would call use a variable or a function inside of a class. You would use the name, colon, and then the thing you want access to. Now I can sit there and go equals, and this is a blah, 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 blah. Just like that. So now this variable current View Params would equal blah, 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 blah. Just like int number equals 5. Same way. This right here is a variable. So is this. This is the class. See, people usually don't know this, but int is a class. It's a type, but it's also technically a class. So we have the class, name of the variable, and then what we're assigning it to. We have the class, name of the variable, and what we're assigning to it. Simple. So instead of just plain old writing this to access the variable, from now on we're going to have to put the from now on we're going to have to put the class name where the function belongs to. So The reason why we're getting these errors here, just like this, underlying, is because, well, first of all, let's look at it. A non-static data member may not be defined outside its class. Well, actually, I don't know why we're getting that error. It's some sort of, all I know is you can't do it that way. You cannot, but I don't know why. I'm not really that advanced in that. But you can't use it like that. But we're going to go over how you can use it. So we have a class. We name a class like we do a class like this, struct, or you can write the word class, C-L-A-S-S. I use structs usually. Same thing as a class. There's a few differences, but well, mainly differences by default. All of these stuff inside this class, the struct here, is public access, meaning any other object of the class or instance of the class or anything outside of this class can use these variables and functions by default. Whereas a class, everything is private unless told otherwise, meaning nothing else outside of this class could use any of these variables or any of these functions because it's by default private. So because I want all these to be public, everybody to have access to it, I made a struct because by default, a struct, everything is public. Everybody has access to it. So then you do struct, name of the struct, opening, closing, remember that semicolon, and then declare all of your functions and variables that you want. That's simple. That's how you create a class. That way your program is a little bit more organized. Okay? And there's other advantages of using classes that we'll explain in other tutorials. It's not just that simple. There are numerous advantages and disadvantages of using classes. But I chose to use a class for this, and because it just makes things a lot more simpler for me. So now you guys know how to make a class, what a class is about, or a struct. You know, I call structs classes because they're basically the same thing. So now you guys know how to create a basic class or a struct. You know what kind of stuff can go in a class or a struct, and you know how to close one and make sure that you do it properly by putting a semicolon at the end. You know how to access, well, you don't quite know how to access variables and functions inside of classes yet. We'll go over that. But you know that you can't just use the name of the variable, the function to call it, because it belongs to a class, and that you're going to need to know some other little bit of information to use this information because it's inside of a class. It's not out in the open in global space. It's inside of a class. So you need to tell it what class to get permission to use it. So in this Rts Camera.cpp, I have a definition because in the class we declared it. See, we declared void return type, create Rts Camera. Now I'm going to tell it what this function does in the .cpp file. Void Rts Camera : create Rts Camera. And that's where this : comes into place. Let me get rid of this section right here real quick, and you're going to see a red line pop up everywhere. And there's a reason for that, because we put void create Rts Camera. First of all, this declaration does not exist. Why doesn't it exist? Because it thinks that it's out in the open somewhere. It says, where is this function? Where's create Rts Camera? Where is it? Well, it doesn't exist. Why? Because this function belongs to a class. Nobody else has access to it unless they know where the function is. In this case, it's in a class or a struct called Rts Camera. So if you made a mistake by typing void create Rts Camera and you want to define what this function does, you wouldn't be talking about this function that's inside this class. You would be talking about something that doesn't even exist yet. So it's not the same thing. In order to say, hey, create Rts Camera is this function that we're talking about, you have to put Rts Camera : Now, like I said, it knows that this create Rts Camera function is from the class Rts Camera. Very, very simple. That's the difference between using a class and just putting your functions and variables out in the open. When you put them in the class, in order to define them or call them, it needs to know what class or struct it belongs to. And you do this by definition. You do Rts Camera, which is the name of the class, colon, and then the name of the function that's in that class. That's how you define. So in order to define a function, remember defining is saying what the function does. So in order to define a function that belongs to a class, you need to write the return type, the name of the class, colon, the name of the function that you want to define. So again, you need the return type, name of the class, colon, the name of the function you want to define. Then you can go ahead and do all of your defining on what the function does. Very simple. So that's the difference between class. Something belongs to a class, you're going to need to tell it which class it belongs to. You just can't call it like it's out in the open. So in order to call a function or use a variable that's inside of a class, you need to tell it what the class is. Okay? And that's what we did here. So we're defining the function create Rts Camera. We need the return type, the name of the class this function belongs to, colon, and then create Rts Camera, which is the function. Very, very cool, right? So we created a function, we created a class with all these functions and variables. Then we go ahead in the CPP version of the file, we went ahead and defined those functions, what the functions does. So let's go over from top to bottom, and again, this is the basic explanation, just like the same formatting I used in the first explanation, first tutorial in C++. We'll go over more of why we do it and what it, why we do it, and more in detail of what everything means a little later on. So right here, we have the MPI view system equals global environment, P game framework, get iView system. So what is this? If you remember correctly, get iView system is a function. See, it has the little opening and closing parentheses. It's a function. So what does this function return? If you look at the code hints, it returns a variable of type iView system. See the first little section? That's its return type. So this function returns of type iView system. So I need, in order to put that variable into something, I need to put it into an iView system variable. Because it returns an iView system typed variable, I need to put it into an iView system typed variable. Remember my last tutorial? And this variable here, look at the first code hint, it's an iView system. Well, I don't see where we put iView system at all. How do we know this variable is of type iView system and not of type int or something? Because we don't see it here. That's because this variable belongs to the class. So let's go back in the class here. Let's name it PMP iView system. So let's go back in the class and let's look at their variables. Oh, look at that. Pointer, MP iView system. See, we made a variable called, or a pointer called MP iView system. MP iView system. And it's of type iView system. So we did. In our class, we declared that we're going to have a variable called MP iView system, and it's going to be of type iView system. So I'm using that variable right here. I declared it, now I'm defining it. I'm saying, hey, that pointer MP iView system equals iView system. Get it? So the get iView system function is returning a variable of type iView system, which is the view system, and it's being stored into the pointer that's part of the class MP iView system. So just like our last tutorial, if you wanted to use the view system, any functions or variables that's in the view systems, we can just start using this variable right away because this variable equals the view system, right? Very, very simple. All of these M's, by the way, are a naming convention and they're not really needed. You may be thinking, why is there an M underscore? Why is there an N underscore? There's no specific reason. It's just to let me know that it's a member variable. M underscore is usually used for a member variable. And it's just something to let me know, hey, this isn't just a regular variable. It's a variable that belongs to a class member variable. If I go in here, you can see these are variables that belong to a class, so they're member variables. So for me to just know for myself I put an M underscore to let me know this isn't a regular variable. It's a variable that belongs to a class. That's why I put the M underscore. Well, I got to pick up the pace a little bit. I'm going a little bit too slow. So we got the, we already described what this was all about and what pointing this to this and this was all about. So it's not really going to go over that in this tutorial here. So I put the iView system into a pointer that belongs to my class here. I put the entity system by calling that function getEntitySystem into a variable that's part of my class. Remember, it has the M underscore. And that variable has a type, remember, iEntitySystem. So in order to put a, look at the return type, iEntitySystem, in order to put that into a variable, a compatible variable, the variable needs to be of type iEntitySystem as well, and that's what that is. Assign our camera entity in the game world to a pointer named mpiEntity. Here we go. We find entity by name, and the return type is iEntity, so we put the entity into a variable called mp-game-camera-entity. Here we get our camera's entity ID and store it into a variable named mViewID. Oops, that's wrong. I changed it up. Named mEntityID. So mp-game-camera-entity, if you remember correctly, mp-game-camera-entity, mp-game-camera-entity, what does it equal? It equals our entity. Remember, it found the entity and put it in here. So now we're going to take that entity and use its function called getID. This getID returns an entity ID variable. So we put it into an entity ID variable. So this now equals the entity's ID, our game camera's entity ID. Now we're going to activate our entity in case it isn't already. So again, we take that entity, we use its function, remember the pointer? We use its function called activate. And its parameter true. Yes, it is activated. If we don't want it to activate, or if we want to deactivate it, you would put false here if you want to deactivate. But we want to activate it. So we take our entity, because it was assigned up here, and the entity of name game camera was assigned to this variable here. So we're using that variable to talk about the entity, and we're calling its function called activate, and we're saying yes, true, activate it. Here we're creating a new view and assigning it to the pointer named mPView, which is that's changed since last time. It's actually being put into MP Rts Camera View. And these are all member variables, so they're all part of the class. mpiView system, it talks about the view system because we assigned it up here. This function right here got the view system, and it put it into our variable here. So now we're talking about the view system. We use this. So we got the view system, and we're using the view system's function called createView. CreateView is returning an iView type, which this variable here is of type iView. And you can just see that here. Rts Camera View is of type iView, just like that. Now we're going to get the view ID of our new view by using the variable Rts Camera View ID, right? So we're going to use the view system. We're getting the view ID, and what is the entity that we want to get the view ID of? Well, our Rts Camera View. Remember, Rts Camera View equaled our new view. So we're getting the view ID of our new view, and we're assigning it, see, equals, we're assigning it to our variable called mRts Camera View ID. So now this holds the ID of our new camera. Then we're removing the currently active view. In case there's one already active, we want to remove it. We don't want to use it. So, remember, we use the view system, calling its function remove view, and then the view that we want to remove. I just use the mView system, right? Get active view ID. So this is a parameter here. See, the remove view function takes a parameter because you have the opening and closing parenthesis. What's the parameter? Well, the parameter is what view we want to remove. But since we don't know what the currently active view is currently, we use a function in the view system called getActiveViewID. So this view system, getActiveViewID, returns, what does it return? An unsigned integer, which is the view ID of the currently active view. What does this remove view take? it takes look at the code hint, it takes a unsigned integer view ID. So we're telling the view system to call its function called remove view, and then in this one we're just telling it what view to remove by finding the currently active view and putting in the view ID here. So we're just removing the view. Set our new view as the active one, which is our view system. We're telling it to set our active view, and what is the view we want to set as active? Well, our RTS Camera view. Remember, RTS Camera view was our new view. So go ahead, set it as active so we can see out of it. This here is another one of my created functions. See, set view, will give initial values to our camera's view parameters. Each camera or view actually has its own parameters, like what is its field of view, what's its position, what's its rotation, how many times is the view updated, etc., etc. That's what I didn't understand before, why it wasn't working. So this calls a function set view params. If you look down here, set view params. But because this function set view params is part of a class, see, set view params is part of a class, I have to put the class name. So void Rts Camera, the name of the class, colon, the name of the function. And then I can just go ahead and define what that function does. So, at this line, I call a function set view params. So it goes over here, finds the function, it does it. Because this set view params is the function that belongs to a class, remember, I did the name of the class, colon, set view params. So when we call this function, set view params, we tell it, hey, when you go over to this function, bring over this stuff here. So when you call a function, remember we talked about there's three different things mainly about a function. There's the declaring, saying we're going to have a function named this, and this is return type. And then the second part was defining it, saying, hey, this is what the function does. And then the third one was calling it, saying, hey, do this function. Well, when you call, hey, do this function, set view parameters, you can tell it to take a couple of variables with it. Oops. And that's what we're doing here. We say, hey, do this function, opening, closing parentheses. Everything inside here is, hey, bring this stuff with you when you go to that function. So we have three things. When we call the set view params function, we bring over the RTS Camera view ID, which is the ID of our camera. We bring over the entity ID, entity ID, which is the entity ID of our game camera entity. And the third one is the actual camera entity. So again, when we call this function, when it calls it and it goes to that function, it's going to bring along with it the camera's view ID, the entity ID of the entity, and the game camera itself. And there are three parameters. You separate them by comma. So first parameter, comma. Second parameter, comma. Third parameter. Just like that. So it says, okay, I'm going to go to this function now called setViewParams. So it goes ahead, it finds it. Oh, here it is. Found it. So now this is mapping. Okay, very important. I'm not going over exactly how to make functions with parameters. You should know how to do this if you're getting into the C++ with Cryengine. You should know how to do this already. So it's just assuming you have basic knowledge of parameters. Arguments and functions. So we sent over 3 into this function setViewParameters. And this is like the mapping stage. You can look at it. What was the first parameter? The first parameter was our view ID, which is of type, let's hover over it, uint8, unsigned integer. Its type is unsigned integer. So we have comma, comma. So we have 1, 2, 3 parameters. that this function can take. This says, this is the name of the function, set view parameters. And, okay, so, I'm sorry. When we're defining, when we're saying, I'm sorry guys, when we're defining and saying, hey, this is what the function does, we can say, these are the things that it's allowed to take into the function. See? These are the things that are allowed inside of the function. Here, when you call it, you tell it, these are the things to go with to the function. When you're defining, these are the things it can take in. So this can take in 3 parameters. So what do? We sent 3 parameters. Because when we defined our function set view parameters, we told it that it's going to take in 3 parameters. So when we call it, we have to send in 3 parameters. That's what we did. So when you call a function and you're sending 3 parameters with it, it maps them. Parameter 1, which is our camera view ID. Parameter 1, camera ID. Parameter 2, entity ID. Parameter 2, game camera ID. Parameter 3, MP game camera entity. Parameter 3, game camera. They're all the same type. Parameter 3 is of type iEntity, and so is the game camera entity. See? Quotients iEntity. Parameter 2 is of entity ID. Parameter 2 is of entity ID. Parameter 1 is of type unsigned integer. Parameter 1 is of unsigned integer. So, parameter 1, so the value, okay, so what's this? Rts Camera View ID. What is the value of that? Rts Camera View ID, what is the value? Let's see. Oh, it's the view ID, right? This variable here holds the view ID. So what happens when you send parameters like this along with function calls is it brings over that value. So this value, let's say the camera view ID was 13. When it goes over to this, 13 gets put into this variable you created called camera ID. So yes, they're different names and it could be kind of confusing. Like this is a different name than this first parameter. This is a different name than this second parameter. And this is a different name than our third parameter. So it's really not that confusing. What it means is when you created the function, so remember when you declare a function, you tell it, hey, this is a function, and this is what the function does. We put the return type, the name, and then we just said, hey, this function is going to have some parameters, and this is what it's going to be. The first parameter is going to be of unsigned int, and the name of the variable is going to be called camera ID. We're going to have a second parameter called game camera ID, and it's going to be of type entity ID. And then we're going to have a third parameter called game camera, and it's going to be of type iEntity. So when we define it, we have to do the same thing. Void, because it's inside of a class, we put the class name, the name, and then exactly what you wrote on the definition, declaration. See? Unsigned int camera ID, entity ID, game camera ID, entity game camera. So when we call this function set view params, we're telling it, because it has to, we set it up that in the beginning it's going to take 3 parameters, so we have to give it 3 parameters. Whether they're going to be used or not, it doesn't matter. It has to be given 3 parameters. And basically, it's taking the value. Let's say this was 13. The entity ID was 10. No, let's say this entity ID was, the view ID equaled 10. And then the entity ID equaled 9. And then the game camera entity was Paul. Or let's say game camera entity was camera. Okay? When it sends it over, it basically maps it, saying, okay, this camera ID variable now equals 10. This game camera ID now equals 9. This game camera variable now equals camera. See? See what I'm saying? So the value of parameter 1 is mapped to parameter 1. The value of parameter 2 is mapped to parameter 2. Parameter 3, the value of that, is mapped to the parameter 3 value. So even though they have different names, all it's doing is it's taking the value out of the first parameter and putting it into the first parameter. It's taking the value out of the second parameter and putting it into the second parameter. It's taking the value out of the third parameter and putting it into the third parameter. That way, you can use variables that are inside of this function and use them in a different function. Because in C++, remember I told you in the beginning, this is called a scope, meaning anything with an opening and closing curly brackets, anything that's in here cannot be used inside of something else, opening and closing. So anything in here has no memory of anything inside of this. So you can't use any variable here that was described in here. You can't. And that's why we're doing this. We're calling the function and we're telling it bring these variables that are from here into these variables. Now the only difference is, instead of using, let's say we sent over Rts Camera View ID for the first parameter, we couldn't write Camera View ID. We couldn't use that in here. We wouldn't know what we're talking about. That's why we use Camera ID instead. So instead of writing Rts Camera View ID, we're going to be writing Camera ID inside of this function, because Camera ID now has that value of the first parameter up there. This Game Camera ID now has the value of the second parameter up there. The third parameter here, Game Camera, has the value of that third parameter. So now instead of using these names here for the variables that we're talking about, we're just going to use these. And that's what's called bringing over variables from one function into another and using them. That's very, very simple. I hope you can understand that well. So that's what we did. We called the function setViewParameters. So what is it going to do? It's going to do all of this stuff. It's going to do all of this stuff. Just like that. And this camera ID, game camera ID, and our game camera is the same exact stuff as Rts Camera View ID, Entity ID, MP Game Camera. They're the same thing. We're just using a different name because you really can't bring over those variables into another function. So we're just mapping them to different names. So parameter 1 equals parameter 1, parameter 2 equals parameter 2, parameter 3 equals parameter 3. Now we can use those values in this function by just using these names instead. It's really hard for me to explain this, so I hope you understand. And if you know C++ already, you guys will know. That's why I said you need prior knowledge, because I'm not good enough to explain it, good enough for beginners to understand. We really need to look at some tutorials on functions with arguments. Okay, so search the web for functions with arguments. Search the web for global versus private variables. You'll find some videos or information on it. And you'll see exactly, you'll be like, oh, so now what he was saying is so clear now. I understand it. So yeah, if you have trouble, just look up some videos on what the heck are parameters or arguments inside of functions, and you'll find exactly what I'm talking about. So now that we called this set view params that we made, we did current view params. Oh, by the way, current view params. What is it? Well, it's a variable in our class. Current view params. And oh great, I'm going to have to go over a separate thing with this too. You ready? All right. Bear with me now. There's a lot to learn. So, if you notice really carefully that this variable here doesn't have a multiplication symbol. This variable here doesn't have a multiplication symbol, but this does. This does. This does. This doesn't. This does. So what's the difference? The difference is this is not a pointer. It doesn't point to an already existing class, right? And this pointer, this thing right here, is a pointer. So it points to an existing class. So by using this pointer here, MP Game Framework, we're able to access the functions that are in the iGame Framework class. Same with this. By using the MP Entity System, pointer, we're able to access the functions that are inside of the entity system. But this mNew View Params and the mCurrent View Params, they're not pointers because it's basically making a duplicate or an instance. Meaning this is not a pointer, it's called an instance or an object. They're both the same thing. Some people call them instances, some people call them objects. They're the same thing. So instead of making a pointer that points to the SViewParams class to use its functions and variables, you're making an object or instance of this class. Okay, it's a little bit confusing. So what this is this is a pointer. Look at all these pointers here. Even if I'm not highlighting the one currently you're looking at, just take a look at all of these pointers, the one with the multiplication symbols, and look at their types. iEntity, iView, iGameFramework, iEntity system, iView system, they all have pointers to them. That's because, let's look at the iView system. Are you ready? Let's look at the iView system. iViewSystem.h, and if you remember from the last tutorial, that is in the cry action. The CryEngine's already existing header files and for functions you can use and stuff. So iView system, that's iVehicle system, iView system, and let's look at it. So right here we created a pointer called mpViewSystem that lets us access the iView system, and we created a pointer for a reason, and we didn't create a instance or object. There's a reason we created a pointer for this and not a instance or object, because we can't. With the iViewSystem class, we cannot create a instance or object. We can only create a pointer. So just as a general rule of thumb, think of this. If the class allows it, use an object or an instance. Do this. If this class allows it, use an object or an instance, not a pointer. If the class does not allow objects or instances, like this class, use a pointer. So with this, and with the non-pointer and the pointer, they do exactly the same thing. It's just they're different ways of doing it, because this does not allow instances or objects, so we just use a pointer instead. Since this class does allow objects and instances, we use objects or instance instead. Same thing. So if you can't use an object or instance, use a pointer. If you can't use a pointer, use objects or instance. That's all. They're basically the same thing. And we're going to go over how you know if it can use it or not. So let's look at the iView system and see why we can't use an object or an instance, and instead we have to use a pointer. iView system. So let's look at the iView system. Right here, see? Class or struct, right? iView system. And clear straight away. Do you want to know why you can't use an object or an instance? Simple. See this virtual keyword here? See the virtual? That's why. If a class or a struct has any virtual functions or virtual anything, if you see that virtual blue keyword here, if you see that virtual word inside of a struct or a class, you cannot use an object or instance. Clear cut. I'm not going to go into it deeper. That's just plain and simple. If you see the virtual keyword inside of a class or a struct, you cannot use an object or instance. You're going to have to use a pointer. Plain and simple. Let's look at the SViewParams class. Let me right click on it, go to declaration. Well, let me go to definition instead. See? We have a struct or a class SViewParams and opening. Let's go down way to the bottom. And closing. And do you see any sort of virtual words in here? Virtual keywords? No. So if you don't see a virtual keyword in the class, use an object or instance. If you see a virtual keyword in there, use a pointer. So for the SViewParams, we don't make a pointer. We make an object or instance because we don't include the multiplication symbol. But because the iView system has a virtual keyword in it, and then we're going to use a pointer by putting the multiplication symbol. That's different. I mean, that's the only difference. That's how you know whether to use an object instance or a pointer. Now there is one little extra step you're going to have to know. I know it's confusing. This, that. What the heck? This is confusing. But let me just hopefully ease your pain on this and lessen your confusion. With pointers, in order to use functions, we did this, right? This is a pointer, and we use this to call its function. See that? For a pointer, we use the dash and the greater than symbol to call its function. But with the object or instance, you use a dot instead. That's it. So with the object and instance, you use a dot. And then this is its variable here. See it? Very simple. If this were a pointer, we would do this. Like that. We get an error because it's not a pointer. But see, if this was a pointer, we'd use that. Because it's an object or instance, we use a dot instead. That's very, very simple. Cool, huh? So let's go over this. I'm glad that I've lessened the confusion for you, I hope. And now we can get back to what the deal is. So after that, we call the function set view params, and we send over the values of our variables here. Now that we're in this function, we can use those values and variables because they're now mapped to different names that we can use. So current view params is a class, and we're using its variable called position. And what does the position equal? Game camera get world position. So what is game camera? What the heck is it? Remember, we're using game camera now. Well, game camera, if you remember correctly, is the same thing as, let's look at the third parameter up here. Oh, MP game camera. That's a third parameter. This is a third parameter. So they're equal. So what was this? MP game camera entity, MP game camera entity, MP game camera entity, MP game camera entity. Oh, okay, I see. The MP game camera entity was our entity, our camera entity in our world. So when we're saying game camera, we're talking about our game camera camera entity in our world. So we're using that entity, our game camera entity in the world. It's a pointer, right? So we're going to call its function get world position. So the game camera entity in our world is calling its own function called get world position. And this world position function, it returns in vector 3 type of its x, y, and z position. So this mCurrent view params dot position variable now equals the game camera's x, y, and z position. So essentially what we're doing is we're saying we're telling that our view's position is going to be the same position as our game camera entity. Same thing, we're telling it that its rotation, our view's rotation, is going to be the same as get world rotation. It's going to be the same as our entity's rotation. We're saying that the view's near plane is going to be 0, and you're going to want this put 0 by default, 0.0f. The f means it's a float, meaning it's a 1.2, 1.3, and not a 1, 2, 3, 4. If there's a decimal involved, it's a float. So go ahead and put an f at the end. This is a FOV, field of view. So the camera view's field of view is going to equal, now this is another thing that was, after I found out how to make the lines, black and white lines go away, I was still having issues. I could see stuff, but it looked like blurry, and I couldn't see really anything, but the lines weren't there. And this is because field of view, you guys know what field of view is, obviously. You got 50, 60, 70, any type of field of view. But I was putting 60.0 because I wanted 60 field of view. Wrong. It's 0.6 for 60, 0.7 for 70, 0.8 for 80. So it's point whatever. So if you wanted a 10 field of view, you wouldn't put 10.0, you'd put 0.1 for 10. So there we go. So the field of view of this current camera is going to be 0.1. 60. It's going to be a 60 field of view. What is the view ID of this camera going to be? Well, it's going to be camera ID. What was our camera ID? What was the first parameter up here? Camera ID? Camera ID. Oh, our RTS camera ID. So our camera's ID. So our camera's view ID is going to equal camera ID, which, if you remember, is our camera's ID. Is it going to be, is our camera view going to be ground only? False. It's not going to be ground only. What's its shaking ratio? Is it going to be shaking? 0.0. No, it's not going to be shaking at all. 0.0F. Is our view's current shake quaternion, which is like our rotation? It's going to be identity. Identity means 0, 0, 0, 0. That's what it means. Identity means 0, 0, 0, 0. It just renamed identity. And what about its current shake and shift? What's that going to be? 0. You can't type in the number 0 because that's 1. This current shake shift variable is of type vector 3 if you look at the code hints. And 0 means 0, 0, 0. See vector 3, x, y, and z. 0, 0, 0. 0x, 0y, 0z. So 0 means x, y, z. So 0 means 0, 0, 0. Identity means 0, 0, 0, 0. 4 zeros for identity, 3 zeros for 0. And what is the camera's target going to be? Well, it's going to be our game camera ID. It's going to be our game camera. Remember? Game camera ID. So what is our ID of our camera? What's the target that the camera's going to be looking at or following? Game camera ID. But what is game camera ID? What's the second parameter up here? The game camera ID is the entity ID. But what does entity ID equal? Entity ID. Oh, it's our game camera's entity ID. Cool. So when we're talking about the game camera ID, we're talking about our camera entity's ID. So that's going to be its target. What is the what is its target? Remember, because this is telling it what is its target, which is our game camera entity. And what's the target's position? Well, it's our camera entity, its own function, get world position. Very simple. What's the frame time? How much frames per second is this camera going to update? It's going to update 60 frames per second, 60.0F. So this camera view is going to update 60 frames per second. M current view params, angular velocity, 0. It's not going to have any sort of velocity type physics movement, so 0.0F. It's just directional velocity. Our view's directional velocity is going to be none, 0.0F. Our current view params distance, meaning the distance from our target, the distance from the camera target, it's not going to be any distance. It's going to be in the same spot as our camera, so 0.0F. Is the view going to perform any blending? No, it's going to be false. It's not going to perform any blending at all. Pretty cool, huh? So after this function's done, it goes back up to where it was called, which is right here, and then it continues down the rest of the code. After, see, this called the function, bringing over these variables. This maps the variables to new names, and then this is the function. After this is all done, it says, oh, we're all done, let's go back to where we were called, and then it continues. Just like that. So this set view params, okay, see it, set view params, is in our class as well. Let's go to the functions right here. Type void, set view params. Pretty cool, huh? And so we set the view params. We said, hey, the camera view's parameters, like the parameters of, or the settings basically, of our camera are going to be all of these. Its position is going to be this, its rotation is going to be this, its near plane is going to be this, its field of view is going to be this, blah, 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 blah. After it's done, it says set view params for our camera. Now this is a already existing function. See, MP Rts Camera View. So now I'm accessing the view system, Cryengine's view system, and I'm calling its function set current params. what are the params we want it to have? That's what this parameter is. M current view params. See? M current view params has all of these variables right here. M current view params is a class that has the position information, rotation information, field of view information, view ID information, its target information, its velocity, its blending information, its distance information. So what are we going to do? We're saying, hey, view system, go ahead and set this camera's parameters to M current view params. Set our current cameras with all of these parameters. Pretty cool. So now our new camera has new parameters. The parameters it has are all these because the function before this, we told it to change all the parameters to these. Now this is saying, hey, now that we changed the parameters, go ahead, take the view system, use its function called set current params, and set these as the parameters. M current view system, M current view params, M current view params. So all of this information is now going to be what the camera's current parameters are. Pretty cool, huh? Pretty cool. We're almost done, guys. We're almost done. After that, the final step, after we set the camera as active, remember we set our camera as active, we switched out the parameters for new ones with this function here. Then we set the parameters of our current camera with the view system with these new params. And we're now finally linking our view to our game camera entity that's in our world. So we're taking our new view where we created, see, MP Rts Camera view. What was that? MP Rts Camera view. Oh yeah, that equaled our new view that we created. So we're taking our new view we created, using that view's function called link to, and we're linking it to our game camera entity. What was our game camera entity? Oh, okay. It was our entity that's in our world. So now our view is successfully linked, meaning it takes on the rotation and transforms as our game camera entity in our world. That's fine. With this function here, and this function here, we've successfully set up the functions for creating a camera, setting its parameters, and linking it to our entity that's in our world. And we did this with the class. So all of these variables, all these functions, see, functions, all of these variables, functions, variables, all belong to a simple package deal, this class. So we did. We made one class called Rts Camera, a nice little package with all of the functions and variables that we need. And then we just used them. We told it what class it's coming from, and then we used it. We used that function. Simple. Oh, the reason why we don't need to tell it where MP view system's coming from, because you don't see Rts Camera : Rts Camera : MP view system. You don't see that. And you're like, okay, are you lying to us? No. What it is you don't need this because it's inside of a function that already has the Rts Camera. It already knows. So void Rts Camera is the class that this function belongs to, and the name of the function. This is what's inside of the function start, and that's what the inside of the function close. So anything inside of here, it already knows what class this belongs to. Why? Because it's done inside of a function that already knows where it's coming from. So since this function definition knows that it's from Rts Camera, then all of these variables will automatically know that it's from the Rts Camera. Why? Because it's inside of a function that it already knew what class it belonged to. Had these not been inside of a function that already knows about what class it's from, you would have to put either a Rts Camera dot MPVUI system. See what I'm saying? Since these variables are inside of the function which already knows about the class, we don't need to tell it which class it's from. It already knows. So if I hover over it, see how it says Rts Camera : MPI view system? Well, this is the MPI view system. What's the first part? Rts Camera, : Rts Camera, : So this variable already knows that it's from the Rts Camera, : class, right? Right. So that's why. This variable does not need to know where it's coming from because the function that it's in knows about it. So everything inside of this function here is going to know which class it belongs to. Pretty cool. The only thing left to do is call these functions because we've defined them, but we won't do anything because we didn't tell it to do these functions. So let's go over to our game.cpp like before. And in the game.cpp, let's go over to the cgame namespace and then go to its update function. See, this is like the function browser over here, and this is the namespace browser over here. So let's go to the cgame and then update function, and it's right here, update. See, just like ours. Ours is a return type, cgame is the name of the class, update is the name of its function, and it has parameters. So, see, that's what Cryengine has. Same thing as what we did. We have the return type, name of the class, name of the function. Pretty cool. And this is what the function does. So I went all the way down to the bottom at the end of their code, and I added my code right before the returning. Because remember, once you return, see this keyword return, once you do that, nothing after return will run. So make sure you put your code before the return happens. Ugh. So inside of the game.cpp, this is all I did. That's it. That's all I did. All I did was this. This is my calling. And this is what happens. Before, in our old tutorial, the reason why it wasn't really functional code, part of the reason, and mainly the reason why it wasn't really functional code is because, remember I told you this update function here gets called every frame? It was creating a camera every single frame, creating a camera every single frame. So like I said, after 10 minutes, you could have 1,000 cameras, and that's not good. You don't want that. You want to create one. So this is what I've done in the update function. I created a string. Okay, created a string called level name. Well, first of all, I wanted to explain what this function does. In order to run this function only once, I do this. I check when the level is loaded. Once the level is loaded, do that function. After that function, don't do it. That's what this function does. That's what this is doing. I'm just describing an overview of what this little section is. Because I didn't want it to create every single frame. Because this function is run every single frame, I wanted a way to control how many times it's run. I don't want it to run every frame. So I made a little thing here that says only when the level is loaded do the function create Rts Camera. As soon as it's done, go ahead and don't do it again. So let's go over what I did. Remember I told you making an object? Well, because my class Rts Camera doesn't have any virtuals in it, I can go ahead in order to use these variables, okay, in functions, or in order to use them, what do I need to do? I need to have either a pointer or an object or instance to use these, right? In order to use these functions and variables and call these functions and call these variables, you need to use a pointer or an object instance. So I'm in the game.cpp file, and I'm not, I repeat, in a function that knows about its class it's coming from. I'm in the game.cpp file, and it's not in a function. The name of the function that this is in, I'm calling it from, is the cgame update. So because I'm not in a function that knows about what class that these functions are located in, I have to create an object or an instance to tell it these are the class it belongs to, and go ahead and run this function. So I do. So let's go to the bottom of the update function right here. So let's hover over that. So at the top of the page, before any code is run, it's called, I'm making this global. I'm making this object or instance global, meaning that it's not within, remember, if it's not within inside of an opening or closing curly brackets, it's considered global, and every function can have access to it. So that's what I did. I created a instance of my Rts Camera class, because it's not inside any opening and closing, it's global. So that, let's say this, let's go down a little bit. See this function lobby configuration callback? I can use that object or instance in this function. I can use it in the init function. I can use it in any function I want in this CPP file. Why? Because I made it global. I didn't put it inside of any opening and closing curly brackets. I put it just out in the open. So I made a object or instance of the class. So I put the name of the class, Rts Camera, no multiplication symbol, and Rts Camera 01, which is the name. So again, I made so in order to access any of these functions or variables, I need to make a pointer or an object instance. Hold on a second. Hold on. Yeah. Yeah. Yeah, no problem. All right. So I obviously want to call what function? I want to call the create Rts Camera. So in order to do that, because it's inside of a class, I need to make an object or an instance or a pointer. But because this does not have any virtual keywords in it, I can just use an instance or an object. So I do that. Rts Camera, which is the name of the class or the type, and the name of the object instance, Rts Camera 01. Pretty cool. So now I have the object and instance, which is named this. I can go ahead and call those functions. So let me go back to the update function. Let's go to the bottom. Okay, so I'm having a string. Okay, string level name. So this is a variable. It's just a regular variable called level name. It's of type string. If you remember, string is like a word: cat, dog, mouse, right? That's what it equals. So this level name. What does this equal? It equals Rts Camera 01 dot get level name. See, I'm able to use this get level name function. Let's go to my class Rts Camera. Oh, string type get level name. So this get level name function that I created is inside my class. Because it's inside the class, I had to call it with an object instance. See, object instance. And remember, with objects and instances, you don't use the dash and the greater than symbol, you use a dot. So from this class, I want to call the get level name function. And what does it return? Of type string. See, string. So this is going to return a string. It's great because it's going to be put into a string variable. So the level name is going to equal whatever comes out of this get level name function. So it's going to go ahead and it's going to call this get level name function. And where is it? Get level name. Oh, okay. So I have a function string Rts Camera. Remember, I need the name of the function it's from, and then the name of the function, and then this is what the function does. So level name will equal whatever comes out of this or returns from this get level name. So it goes ahead, it calls get level name, it does it. MP game framework, which is a variable inside of my RTS, MP game framework, right, is of type iGame framework. So I don't need the Rts Camera .mp game framework because it's inside of a function that already knows about which class. So I'm using that member variable game framework. What does it equal? It equals the game framework. See, game framework. So string level name equals MP game framework, right? What is the MP game framework? Oh yeah, equals the game framework. So that's calling a function called get level name. Don't get it confused with my function get level name. This get level name is actually the Cryengine's own function called getLevelName. And this function that Cryengine has as part of the iGameFramework class, it gets the level name. It gets what level name you're currently in. If you're not in a level and a level is not loaded, it returns nothing. It returns a empty string like this. Boom, boom. That's an empty string. Opening and closing means it returns nothing. There's no name. If it does return a name, it'll return the name like that. That would be the name if it has a level that's loaded. If it doesn't have a level that's loaded, it returns this. Empty string. Nothing's loaded. No level is found. So the iGameFramework is calling the getLevelName function, and that's Cryengine's own function, even though it has the same name as mine. Don't get confused. It calls that function, and then what does it return? It returns a constant character, which is like a string. It's a string. So string level name. So level name equals whatever the current level is loaded, right? It equals whatever the current level is loaded. And then I return level name. So I return level name. So if this, let's say right here, see this right here? Level name. Let's say if there was no level loaded, and this gets assigned a blank level, like the nothing in it, the blank level, I'm going to return that. I'm going to return level name. And that means it's going to return from where it was called. And it was called here, correct? So this went ahead and it called the getLevelName function. It did it. It took the level name, put it into the variable, then it returned the variable back to where it came. And so it had blank, had nothing in it. So that gets assigned to level name. So now level name here equals blank. There's nothing in it. So then I check if level name does not equal empty string. See, does not. Does not means does not. And you say it like this. Exclamation point equals. This means does not. That means equals. So if level name, so if blank 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 is not the same as empty string, what's empty string? It's a variable. And just like the object or instance I made, I created a string called empty string. See, string, empty string, I put it in global space so that any function can access it in this file. And what does empty string equal? Blank space. Empty string is an empty string. Empty. See, nothing in it? Pretty clever that I named it empty string, right? Wow, genius. It's empty. Nothing's in it. So let's go back to the update function. Let's go down. It's confusing, but I think you guys are going to understand this pretty well. I think I'm explaining it pretty well as well. So, remember, level name, because we found the level name, we called the function getLevelName, then it found the level name, and then it returned the level name, and assigned that level name to here. So let's just say that level name, there wasn't a level loaded at all, because it returned a blank string. So then it's checking if blank string, see, blank string is not the same as empty string. And what is empty string? Empty string we saw up there is this. So if this is not the same as this, then do this. Okay, that's what if statement. See an if statement here? If, and then you do an if statement like this. You put if. This is if you check if. If this is true, this is an if statement in general. This is what happens. If, and then you have a condition in parentheses, opening and closing parentheses. If this is true, then do whatever is in the opening and closing parentheses. That's what an if statement is. You're checking if something is true. If something is true. So you put if, and then the condition, bam, true, then do whatever's inside this. Do this. So if this is true, do this. And if it's not true, it'll just skip over this entire if statement. See, if it's not true, if this is false, it'll skip it over. It won't do it. So here we go. So now level name, let's just say, the level isn't loaded. It came here and it says, hey, there's no level loaded, and it put a blank string inside here. And it checks. If blank string is not the same as, is not the same as blank string, then do this. Well, as you can see, level name is the same as this. So it does not do this. Because we're checking. Is this not the same as this? Then do this. But since this is the same as this, it just skips over. Because this now equals false. See? This only happens if the condition is true. If the condition here is false, it skips over this and it doesn't do it. So in an if statement, if the condition is true, it does this. If it's not true, it skips over it. So the condition is level name, if the level name does not equal empty string, then do this. But since it does equal empty string, because these are the same, if it does equal empty string, then it doesn't do it. So that's how I avoid it. So when Cryengine is booting up and the launcher is going and I'm selecting a level and blah, 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 it never creates the camera. It never does. The camera is never created. Why? Because these two are the same. It doesn't have a level. But it keeps going and going and going and going. And once that level is loaded, when it comes around and it does this and it says, gets the level name, and it puts the level name in here. Say the level name was shipyard. Let's just say shipyard. So it did this function, it got the level name, it came back, and now this has shipyard in it, because now it has a level name. Then it checks, is shipyard the same as empty string? It's not. See, empty string is this, remember? Empty string is blank. So let's just write this out. Shipyard. Shipyard is not, if the shipyard is not the same as this, then do this. Well, now it's true. It is true. Shipyard is not the same as an empty string. So it goes ahead and does this. So when the level is loaded and it finds a level and it returns the actual level name, it will end up doing this function. Very simple. Because empty string will always be empty string. There's nothing in it. And a level, once it's loaded, it's an actual level name. If there is no level loaded, then the getLevelName function returns just a blank string, making this be false every time, which skips the creating of the camera. But once there is a level loaded, because that's when I want to create the camera, once the level is loaded, this is going to have a valid name, and it's going to be totally different than our blank string. In that case, because it's not the same, we do this. That's what we do. We do this. So first of all, we create the camera. We Rts Camera 01, create Rts Camera. So we do all of this. Blah, blah, blah. Remember? Blah, 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 blah. And it gets to the set view params. And then it sets the view params. Blah, blah. Now it gets all the parameters. Then it comes back up and it finishes. Just like that. Once it finishes, the camera's created. It has its parameters. It now is in the game world. It has its own field of view, its position, it's linked to the entity, right? And then it does this, empty string equals level name. This is how I say don't do this function anymore, because empty string did equal blank blank, but it doesn't anymore. Empty string is now equal to level name. So this is shipyard, right? So now empty string is going to equal shipyard. Right? So now these are the same thing. So level name was shipyard that we were in. And now empty string is going to equal shipyard. Blah, 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 blah. So now when an update comes around again, it's going to get the level name. It's going to return shipyard. Is shipyard not the same thing as shipyard? Well, it is the same thing. So skip this. Pretty clever. So what this does is, when the game updates every frame, this function's run every frame, blah, 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 every frame, every frame, every frame. It's not going to create the camera, not going to create the camera, not going to create the camera, not going to create the camera. When the level is loaded, this is going to be, if there is a level loaded, the level's done loading, it's going to have a valid name. And it's not going to be the same thing as a blank. It's going to actually have a level name. So it'll do this. And when it does this, it says that now empty string and level name are the same thing. And it's going to do it, create the camera once, then it's going to come back around the next frame, and it's going to say, hey, these are the same thing, so skip it. Come around, hey, this is the same thing, skip it, skip it, skip it, skip it, skip it. So it's not going to create the camera every single frame because we told it, once it does it, once it creates that camera, put these as the same thing. Empty string and level name, same thing. Level name, empty string are the same thing now. So this will always, always, always be false, and this will never run. Thank you very much for watching this tutorial. I still have a couple of things to say, but I'm just thanking you guys for watching this tutorial. The camera is fully implemented in that respect, so I'll even run it to show you how cool. It's just cool, you know. So hold on a second. So when the game starts up, it does the update function every single frame. It finally says, okay, the level is loaded. Once it is, then do this. And it comes, then it keeps going and going and going, and it's not going to do this because these are going to be the same thing now because we said so here. Bam, 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 bam. So we created our camera. We talked about creating classes to group all of our functions and variables into one simple package, which we did. We created our own functions here that belong to certain classes. And we created the camera. We linked it to the player. We set its camera's parameters. Here, in the update function of the game.cbp, we called that function once and only once, and when the level is loaded, and not after, not before. Only call it once when the level is loaded. And now we have our camera in the world because we called it. So it's cool. So we did all of that. Very, very cool. And this is full functional code. You can just copy and paste, and it would work. I did say I was going to explain what the header including was, and including's here. So include, if you look at top here, we have a bunch of includes. So what is includes? Very, very simple. What are includes? Well, first of all, you might see some code here that I didn't go over. These because I was experimenting. I just never got rid of the code. I don't use these at all, like that function there. These two here I don't use. I would just use, when I was trying to get it to work, I was trying different things, and these are not important. They don't work or anything like that. What I went over today, all those functions are all you need to know that work. So what these are is... I'm talking about the level system. See, the MP game framework here has a function that's get level name, and if I didn't include this level system, I'll show you what happens here. Let me just cut this out. Let me cut it out. Hello. Oh, that makes me feel bad. I guess I didn't really need that include. Let me just build it to make sure I don't need it. Might have just had an include there that I didn't even need. Just let it build. It's building up. Oh, I'm also going to go over how to speed up your compile times if you guys don't already know. Because sometimes compiling can take a long time. But I got a neat little trick if you have multi-core processors to speed up the process of compiling. Which is pretty cool. I'll go over that in a few minutes. Come on, build. Oh, by the way, I couldn't upload a video tutorial even if I wanted to. I went without internet for about a week. I couldn't pay for my bill. So I got that recently turned back on. I don't know how long it's going to last, but I got it turned back on. So even if I wanted to, I couldn't have done it. And I'm kind of happy that I can actually program some stuff in C++. I got a lot to learn about CryEngine in C++ and C++ in general, but I can do pretty cool things. I mean, you know, how many people can say that they can do what I just did? I mean, I'm pretty sure there's a lot of people who could, but you know, I haven't seen it. I haven't seen anybody on Cry ever anybody make a tutorial about it or see them. Hey, this is this is my camera I made complete from start to finish in C++. I haven't seen it, so. You know, I feel pretty proud, and it's cool. I'm so glad I kind of figured it out. So yeah, I didn't even need the level system. I don't even know why I included it. So let me just get rid of the, well, first of all, let me get rid of the Rts Camera .h include. Oh wow, look at all those errors. Error. Why? Because, see this Rts Camera, even though we know what class it's from, it still has an error because it doesn't even know that this class exists, because we're in a different file. This .cpp file is a totally different file than this Rts Camera .h file. They're totally different files. They don't know about each other. They're like in each file is in like their own different world. They only know what's inside of their file. They don't have any idea what's in other files. So of course, having that logic, it doesn't know that there's a class called Rts Camera at all, and it doesn't know that there's variables that are named these because they're declared in another file. So what you do is, in order to let this file, the CBP, know about these, you just include that file. See, paste. You write the pound symbol, include, and then in opening and closing parentheses, quotation marks, you put the name of the file, rtscamera.h, rtscamera.h. And this copies and pastes is what it does. So see all of this here? See all of this in the rtscamera.h? Everything in this rtscamera.h file is copied and pasted right here. Everything. So now that we've included the rtscamera.h, it now knows we have a class named this and we have variables named this. Why? Because we told this file that it's supposed to know about this file. So now it knows what we're talking about. That's what including is. Including is including .h files or header files to let it know about stuff in other files. So in order to use stuff in this file, I need to include this file into my CPP. In order to use the iView system stuff that's in here, in this .h file, I need to include the iView system in here. And you're saying, well, I thought, well, you're using iView system stuff, but I don't see you include the iView system stuff. That's because when I included the rtscamera.h, look what was in it, iView system. So now this file here includes the iView system as well, because I included the .h, which included the this Rts Camera CPP includes this Rts Camera.h, so it copies and pastes this file into here. And then the file that I included includes the iView system.h. So now this thing includes iView system.h because it's copy and pasting. Think of it. I'm including Rts Camera.h. That means right here where it says including Rts Camera.h, it's literally copying and pasting everything in this file right here. That's what it is. So in order to let one file talk to another file and know about stuff in other files, you just include them. Don't include .cpp files, only .h files. There we go. Oh yeah, and right to the end of the tutorial, I hope you liked it. I mean, I got a lot of positive reviews, and I got to thank you guys for that. You guys did amazing. And for sitting through my tutorials for like an hour and a half, most of my tutorials are hour and a half, 2 hours, 2.5 hours, and for you guys to sit there and watch them, it's just amazing. I appreciate it so much. And I also appreciate the positive comments that have been left on my C++. The C++ tutorial, as I predicted, has been extremely popular. Not a million views popular, but it's been extremely popular, and I really appreciate it. And it's probably because it is good content. And, the more viewers, the more good comments I get, the more it lets me know that I did a good job and this is what people like. So I just appreciate it. Hope you guys do like it, and let me just go over one more step to show you how to make your compile time faster, depending on how much cores you have. The more core processor you have, the more processing cores you have on your computer. I happen to have a AMD 6 core. I'm going to be getting an 8 core soon. So I have 6 cores. The faster your compile times are going to be. So how you do that is you right click on your Rts game project or Cryengine, go to properties, not in here. You go to Tools, Options, Debugging, no, Project and Solutions, there we go. Build and Run. God damn it. Incorrect again. What the fuck? This is not good news for me. Or for you guys either. Oh, you could make your computer thing run faster. Under Projects and Solutions, Build and Run. So you can tell it to how many projects you want to build simultaneously. That will speed it up, but that's not what I was talking about. You can put how many projects you want to build simultaneously to speed up your process. Oh, this is just bull. I can't even find it. Can't even find it. This is ridiculous. This is ridiculous. This is ridiculous. Oh, okay. Go under, right-click on your project, Properties, C, C++, command line, and type in this. / capital M, capital P. Multi-process. That's what it means, multi-processor, I think. That's it. That will use all of your cores to build. / capital M, capital P. Push apply, push OK. Very simple. Thank you guys very much. Hope you enjoyed. Please comment and rate. In the future, my C++ tutorials won't have their own name because they're part of this series. I've decided that it's going to be like part 4, part 5, part 6, part 7. And in order to see if it's a C++ one or just other RTS related games, look at the description. The description will say, hey, this is a C++ tutorial, or hey, this is just a general RTS one. So this whole project belongs to my How to Create an RTS Game from Start to Finish series. This is part 4, and in order to see what part is C++ or what part is just general RTS stuff, then look at the description. I'll let you know. So from now on, there won't be my C++ tutorials will not have their own name. They'll be part 4, part 5, part 6, part 7, part of my RTS series. Okay? So thank you guys very much. Much appreciated, and have a nice day. Oh, shit. One more thing. God damn it. Let me run this. I got to show you how it works. All right. Let me just push run and push yes. I was writing in code, as you saw earlier, with the blank empty strings and stuff, so I hope I didn't mess anything up. But here we go. Click on yes, and you're not going to be able to see for a second. Just remember that. Alright, you guys should be able to see. And move this over a little bit. Blow up my level. And here it is. I'm in my level. Let me use my arrow keys to rotate my view. See, left, right. See, left, right. Up 90 degrees. It won't let me go up any further. Down 90 degrees. Won't let me go down any further. My left rotation can go around and around and around and around. Right rotation, around and around and around and around. Camera movement is by like this. and my elevation. Camera, you know, up and down based on terrain height still works. Whoop. Just to know, look at my Z elevation, X, Y, Z. Could be a little bit hard to see. 116, see how it's staying the same? And watch that value, you'll see it go up and down based on terrain height. It went up. It's not going down because there's no need. Oh, went down because the terrain went down, went up because the terrain went up, now it's going down. Let's go forward. Oh crap, I think I went under the terrain. Look up. Bum, 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 bum. Oh crap, I don't know where I am. But yeah, everything works perfectly fine. Amazing, huh? Alright then, thank you very much, and I hope you enjoyed.